Okay, so now we talk about the types of crystals. Okay, so first we have tell you, about the atoms, nucleus. What is the made up of? What the constituent, the atoms. It's an electron and proton, neutron. Proton and neutron makes this nucleus. Electron, which revolves around the nucleus. It is atoms. If we have finished about the atoms, now we come to the unit cell. Unit cell is the arrangement of the atoms in a single unit. I mean, the very basic part of an material or solid materials. Okay, so the present of atom, the sitting arrangement of the atoms in a single unit is known as unit cell. And how the unit cell have been repeated further to make a bulk is known as crystal structure, right? So on that basis, you have the 7 different kind of crystal systems. Okay, and how that will relate, I have already told you 3 things. Basically 6 things. First, ABC, and third is alpha, beta, gamma. Right? ABC is A is a base, B is a height. You can say LBH. Okay, so L means length, B is breadth, and C means height. Okay, so that will make your three dimensional, right? And how these three have been placed. Okay, what the angle these three have is known as alpha, beta, and gamma. Okay, so simple. Okay, this is the 7 crystal. Okay, right. So we talk about the first one, which is the cubic. Till now we have discussed the cubic only. Because why? Here it is a condition. A is equal to B, B is equal to C. A, B, C all are equal. Right. And what about the angles? Angles are also equal. And equal. And what that amount is 90 degree. Okay, got it. So if we talk about the cubic, whatever the unit cell till now we have discussed, I have taken the example of all like this. All are cubic, right? All have the same angle. If we talk about this angle, alpha beta means this angle, and third one is this one, this angle. Got it? When if we look here, this is your A, right? This is your B. This is your C, and all are equal. A is equal to B, B is equal to C because it's a cubic, right? And so to be a cubic, it must have the same edges, the same length of their sides. Okay. Now we talk, so A is equal to B is equal to C. Now we talk about the angle. Look here very clearly. What the A, alpha, beta, gamma means. This was the your. Okay. So this is your alpha. This is your alpha. This is your beta. This is your gamma. This one. Okay. So this line makes an angle is a gamma. This this line, and this line makes beta, and this line makes alpha. Okay, and now you can have a confusion about which line we need to know. It irrespective of the line, whatever, if you combine it together, take a 2 lines, and whatever the angle that is in between there, that would be the equal because it's a cube. And cube, what we have a condition, the condition we have here, yeah, this is the condition, and all are equal. So it doesn't matter. What is the alpha, what is the gamma? You can replace anything. Doesn't matter because all equal, all angles are equal. Okay. This is the example. Okay. So diamond are of like cubic structures. Got it. Now we talk about the tetragonal. Okay. So what is the ABC in relation? A would be like B. A would be equal to B, but B would not equal to C. So A, suppose this is your A. This is your B. Both are equal. Whatever the length size is this, the same is this. Okay, but the height. The height means the is a 3D. We will, you know, take like this is your height. Okay. And we make it the 3D. This height, right? This is the height. This is the height. Okay. So this is also same because we have taken A is equal to B. But this height, the height make, this is your height, right? This is this this one, sorry. This one, this one, this one, right? So the height is not equal to C. That could be anything. Got it? So A, B, C are not equal. You can say A, B are equal. Okay. I mean the top faces and the bottom faces are equal. We have made a confusion here. Suppose this is your base, right? And now this is your top. Suppose this is your top. So this is your base. Okay. This is your base. This is your top. So the surface area at the top and the bottom are same. Okay. But the line that will join together, this line, this line, and this one is not equal. Okay. As you can see, this is looking like a something very long. Okay. So that would not be equal to the A and B. Okay. So this is no. Now we talk about the angle, then angle would be the same. All A, alpha, beta, and gamma would have the same angle. Alpha is equal to beta is equal to gamma is equal to 90 degree. Okay. So what is the difference? Difference is only that the height of, you know, the crystal structure is of different as compared to the base and length and breadth. Okay, at the bottom. Okay. So bottom and the top surface would have the same surface area. It means they have the same length and breadth. But the height that make this crystal to the 3D, that is not equal to the B or either A. Okay. So that's it. I mean, you can have the simply like the all have your mobile phone, right? If we talk about the mobile phone and you keep in a as a, in a normal standby mode, okay. So whatever the surface area at the top and the surface area at the bottom, both have the same area, right? If we just consider the the mobile phone as like the very sharp edge at the corner, sometimes we have the mobile phone that has have the round shape at the corner, right? But you if you consider that your phone has the sharp edge at the corner, okay, that phone at the top you have the same area, surface area. At the bottom you have the same surface area, and you can say the length and breadth at the top and the bottom are the same. So that is the A and B, right? That is equal. But if we talk about the thickness of that your mobile phone, that is not equal to the either E or the B, right? As you can see in the mobile, if it the example that I've taken for the mobile, that the length or you can say the height of the mobile phone is a very less as compared to the A and B. Okay, if we take the A as a like A and B, it means the length and breadth, right? If we talk about the height or the thickness, there is a very less thickness as compared to length and breadth. Okay, so here you can consider the angle. Every angle has the same angle of 90 degree. We talk about just considering the edge as a sharp edge. Most of the time, their phone have the corner edge. Okay, a little bit of the chamfer has been given to the mobile phone so that to make a round shape and to have the smooth experience in a hand. That's why they have taken the round shape. But if just consider that is your mobile phone has the sharp edge at the corners, then it is a perfect example of tetragonal, right? But it is a case of the less thickness. Sometime it could be like the thickness would be high as compared to the your A and B. But A and okay, no, I've taken the wrong example. Sorry, sorry. In this case, nobody has asked me. In this case, A and B both are not equal, right? But here the case is A and B must be equal, right? If we take the example of the Philip phone that the Samsung comes. Okay, that could be the very perfect example of that, right? Okay, in the case of mobile phone that I have taken, A and B's are not equal, but the you know orthorhombic. If we talk about orthorhombic, that would be the perfect example of the normal mobile phone that we use. Okay, this is the example of only the phone that Samsung has a Z foldy phone, right? Right. So that have this perfect example of tetragonal. They have the A and B equal. I mean, they have the equal breadth, equal length and breadth, but have the very less thickness, which is your C. Okay, but they have the all the angle are equal. Alpha, beta, and gamma are 90-degree. If we talk about the orthorhombic, then our phone, the shape, the normal phone, that's normal mobile phone that we use generally, that is a perfect example of orthorhombic because A and B are not equal. Okay, here in tetragonal we have the A and B are equal length. Okay, but in an orthorhombic we have the different. A, B, and C are equal, not equal in orthorhombic. But angle, we talk about the angle, then alpha, beta, and gamma all are equal. Equal means, and what the amount? That amount is 90-degree. Got it? Got the idea?
Yes, sir. Yes, sir. Got
Yeah. Okay. So I just messed up something at the tetragonal, but I just corrected myself. So A and B are not equal here. So that would be the of different kind of example that I have taken. Okay. Now come to the hexagonal. Okay. So what is now you have the if you understand these three things, these three, okay, then you would easily relate the next three one because that would not have this practical example right now, so I would have a little bit difficulties to make but if you have understand these three things, then you would easily correlate, okay, what the changes that you need to make in your crystal structure so that to make your next four things. Okay, if we talk about the hexagonal, what you need to change, I mean you need to keep the A, B, C example of the same as you have taken the example of tetragonal. But what the difference is, you cannot have the angle all equals. What the angles are equal? Alpha, beta is equal. I mean, two angles are equal, but there is three, one is not equal. That is have the 120-degree C. Okay, so you can for the hexagonal, you can have the example of tetragonal. Just keep the things as I mean, you can think about the boxes of your, whatever the things, thermocol. Okay, so if you think you have the sides, all sides have been made of your thermocol, and you have just placed with, with glue, you have made the tetragonal, right? Now, what you need to change? You need to change the value of. I mean, you need to keep these three things same. A, B, C, you need to keep same. What you need to change? Even you need to keep the alpha beta value also same, right? Because alpha beta is equal to the 90-degree. What just you need to change the value of gamma. Gamma means the height that you have taken. The height would have not the same angle as you have taken example of the mobile phone or the foldy Z Samsung Z phone. They have the same height, right? Sorry, angle, the height angle at which the height has been given is the same, there's 90-degree. But in this case, you need to give the height, but at a different angle. What is the value of that angle is 120 degrees C. That would be little bit tapered. 120 degree means they have the tapered nature, right? Little bit, tapered means little bit, क्या बोलते हैं उसको झुका हुआ, yeah, right? Kind of bended, right? Now we talk about the diagonal and rhombohedral. So in this case, you have the same example like first one, cubic nature, right? But what is the difference? The all the angles are not equal to 90 degree. Whatever the things that could be, okay, but it could not be the 90-degree. So for the fifth diagonal, you need to think about the box or the cube of the thermocol that has been you made by with the help of glue you have kept. But now you just need to modify. You need to change all the angles. Okay, whatever the angle it could be, anything, but not could it must not be the 90-degree. I mean, any angle of your diagonal must not be 90-degree. Any of them. Okay, irrespective of 90 degree, you I mean you have the lots of I mean if we talk about the 1 to 360 mostly, right? Any numbers that could be except 90 degree. Okay, so think about the first one, which is a cubic. Okay, and then replace the just angles. Okay, you cannot have the same angle. Cubic, we have taken lots of examples so far that have all been of cubic nature. Okay, because in our syllabus, most of the times we are discussing the cubic. I mean, so cubic is a frequently has been used in your syllabus. That's why we use the cubic mostly. But you need to know what the differences and what the other types of crystals are also present. Okay, so keep in mind what crystal, what is unit cell, what is atom, and what is the bulk material. You need have a clear idea about that. Okay, what are the differences between these terms? I mean, you cannot, I mean, sometimes you would have the FCC, I mean the face centered cubic cell at the crystal and at the unit cell as well. Got it? So both face centered and cubic centered, face centered and body centered, both kind of things are present in crystal structure as well and in your unit cell. So don't mess up with these two things. Okay, so if we talk about the crystal structure, then you need to know that I mean the summation of and the combination of two and more unit cell together is known as crystal structures. And what is unit cell? Unit cell is the present of atom. The uh, fashion in which the atom has been present at a very basic level is known as your unit cell. Okay, so now we are discussing, it's not a unit cell, we are discussing the crystal structure. This is a crystal structures. Okay, and before that we have discussed it was your unit cell. So keep in mind, don't get confused about these two terms, because most of the time you will get confused about the cubic. Cubic one has a very confusing natures. Cubic, and also about unit cell. You have, I mean, till now we have discussed the three kind of the unit cell. First one is simple FCC, BCC. FCC means the face centered, BCC means body centered, right? But if we talk about the crystal structure, then we have also the face centered and cubic center, and the extra one is the hexagonal, right? So if we talk about the crystal structure, then they have the also a three kind of things: body center, face center, and hexagonal structures. Okay, so that have the different. You can you can get confused about these two terms, FCC and BCC. So keep in mind what the things has been asked in your questions. If we talk about, if the question has been asked in about um, unit cell, then write accordingly. And if it has been asked in according to crystal structure, then write in that way. Okay, we are discussing the crystal structures. Yes, the crystal structures, right? Okay, so now we come to this one, monoclinic. So what is the difference? Monoclinic, the A, B, C, all are not equal, right? All have the different values. And what we have the relation in angle, the alpha beta would be the 90 degree, but sorry, alpha and gamma. But the third one, I mean, you can say the second one, the beta would not be equal to 90 degree. What basically most of them, listen, suppose this is a very we are taking the example of cubic, right? It's cubic. This one is the very basic, and you can say at the bottom. Okay, so the bottom you have this kind of 2D structure. Okay, so 2D structure 1 and 2, in between you have your angle, and that angle is known as your alpha. Okay, and third one here you will have, this one is your beta, and this is known as your gamma. Okay, so now we can think about, okay, what is the difference between alpha, beta, and gamma. So if we talk about the A, B, C, this is A, this line is A, this line is B, this line is C. C is a, basically it is a height. Okay, so I mean how they are placed at the bottom is known as alpha, and how the one of them have been with the height is known as beta, and third one is your gamma. Okay, so here look, I mean the height that has been taken, that is not been at a 90 degree, right? Beta is not 90 degree, but what is the alpha and gamma is at 90 degree. This is the case in monoclinic. Okay, what is the example? Example of gypsum. Gypsum is a material. you would know about it in a further class and further unit maybe. Then you would have the details about it. Okay, and I hope that you have heard about it. If okay, now we talk about the triclinic. Okay, this is the seventh one, which is the last. Okay, according to your syllabus. Okay, so if we talk about the triclinic, what is the difference? You can easily think about all are not equal. A is not equal to B, B is not equal to C. Okay, alpha is not equal to beta, beta is not equal to gamma, gamma is not equal to 90-degree. Keep in mind one thing. You cannot only say this like this. You cannot say. You have to mention these terms as well. I mean, alpha, beta, gamma are not equal to each other, but still that any of them not must not be equal to 90-degree as well. Got the idea? So this is how we differentiate the seven kind of crystal structures according to your syllabus, right? There are more as well, but mostly we need to know only these terms. Okay. Okay, so these are the seven kind of crystal structures that we need to know. I mean, and there, everything, every kind of crystal structure have their example at the bracket. Okay, so you can think about if you need to know how they have they really look like, then you can just Google it. I mean, the crystal structure of the tin. Then you would have the crystal structure you can think about. You can see. Okay, it's a very basic. We talk about the basic. I mean, the first one, which is a cubic. I mean, first three is very easily you can think about. That's not a very big deal. But rest for all you have a little bit confusion about to understanding. Okay, so you can think you can take the help of the Google. You can go and you can search the example that has been written in a bracket, so that you can see the uh, graphical representation of unit cell and their crystal structures, how they have been placed, how they have been made up of, that you can see easily. Okay.